Alright, let's look at scatter plots and equations of lines. Okay, some vocab that we need to know. The first thing is a scatter plot. This is a display of data from two sets as ordered pairs to help you decide whether one thing is related to another. So it's going to have a bunch of points all over the place. Okay, the line of best fit is a line that is drawn through a majority of the data to represent the trend in the data. This most accurately shows the relationship between the data. Now, a correlation coefficient, that's got to do when we're working on our calculator, and it's represented by R as, you'll hear it as the R value sometimes. So this is going to tell you how closely the equation models the data. Alright, now let's look at some important concepts. First thing, there's three types of trends that you can have. The first one is a positive correlation or positive trend. Either way, they're interchangeable words. It means the same thing. Basically, your data is going to have a positive slope, meaning it kind of, as one increases, so does the other. So a negative correlation or negative trend is when one thing decreases and the other one increases. So it's kind of the opposite. You kind of go down. It has a negative slope. Okay, the next one and last one is no correlation or no trend. That means your data is just all over the place and it doesn't mean one thing and it doesn't mean another. Nothing's correlating. Alright, so the line of best fit, or a trend line as we call it, does not connect the points it goes through the middle of the data. So when it's not connecting our points. That should be a period right there. So basically, it does not connect the points. It's going to be a line that goes through the middle of the data. So it's not going to be like, let's play connect the dots. It's going to be more like a line that kind of fits our trend. So notice my lines, they kind of go through majority of the data. It will hit maybe a point or two that you do have in that data, but it may not hit all of them and it may not hit any of them. But it's going to show what the majority of the points are doing. Okay, a couple other important concepts is when we can actually use the graphing calculator to find a more accurate trend line called the line of best fit. And we'll use the calculator majority of the time to actually find the line of best fit. So a correlation coefficient, and I'm going to tell you right now how to turn it on your calculator. So what I want you to do is go grab your calculators, and I'll wait. Do you have them yet? I'll wait another minute. Alright, now what I want you to do is go to hit the second button and hit your catalog. You'll see it's 0, the number 0, but you'll notice above it says catalog. Hit that. You got it? Now, scroll all the way down to diagnostic on. If you don't want to scroll, you can just hit D. Okay, when you have that, you've got your little arrow pointing to diagnostic on. I want you to hit enter on it and then hit enter again. Now when you find the line of best fit, which we will do in class, you will know how to find the diagnostics and how to find the correlation coefficient. You have to turn the diagnostics on your calculator in order to give you the R value. If you don't have them on, and yes, unfortunately, every time you pull your calculator out, you gotta go and turn the diagnostic on just in case the previous class cleared the memory or did something else on your calculator. So you always want to make sure you turn it on. That way, when you're finding that line of best fit, you actually it will pop up and say R equals and tell you how closely your line is fitting your data. Now, the correlation coefficient is going to tell you basically how strong or weak your relationship between the two sets of data. So the closer it is to -1 or 1, either one, means the stronger the correlation between the data. You'll a lot of times get 0.999 and it will be a long decimal. Okay, if you do, then it's got a real strong correlation. If you got one like 0.0012, something like that, that means there's hardly any correlation. There's really no correlation between the data. Okay, when it's closer to 0 is when the weaker correlation between the data. Now, if you have a negative correlation or negative R, like a -1 or a -0.75, something like that, that means it's a negative correlation. You'll know when it's a positive when you have those positive numbers for your correlation, a positive R, meaning like 0.101 or even like probably a 0.75 or 0.98, that kind of deal. That's a positive correlation. Now, no correlation is when your correlation coefficient is 0 or very, very, very close to 0. That means there's no relationship between the two data. Alright, so now let's actually draw a scatter plot. And you won't be doing a whole lot of freehand drawing of the scatter plots. You'll mostly draw them on your calculator. But I do want you to know how to do it. So here we have, need to make a scatter plot and then draw a trend line and write the equation of the trend line. So I have type of hawks, the length of them, basically how long they are, and then their wingspan from tip to tip. Okay, now I've gone over here and I've plotted the data. So your length is going to be your X value, your wingspan is going to be your Y value. Notice when I am doing a scatter plot, I have a title, like you all should, and this kind of what you do for drawing a table or actually drawing a drawing a scatter plot or graphing your data, even in science and math, and you'll read charts and graphs and tables in social studies and language arts. All of them need to have these key things. One is a title. You can't just give a graph and have no title. We don't know what you're talking about. So you always need a title. The next thing is X and Y axis labels. No. We're not talking about saying, look, this is the X-axis. Look, this is the Y-axis. No. I know what X and Y-axes are. You don't need to tell me that. That's kind of understood. What I'm talking about with an X and Y axis label is tell me, what does X mean? What are you measuring? What are you graphing? So X was the length. So I'm going to put length. Now, I need to put the unit. Inches are totally different than centimeters. A foot is totally different than a mile. So I need to put that in parentheses. Notice on the y-axis, here is my label for my y-axis. I tell you what it is, and I tell you the units I use. Because each unit is totally different than another unit. And we measure things in all sorts of units. So make sure you always put those and what it's measuring. Now, the last thing you need to do is to make sure you actually tell me what each mark is worth. So notice I've just skipped a few, but I kind of tell you what each mark is worth. I know from 14 to 18, oh, that must be 16, going by twos. So make sure you do both. You've got to have titles, you've got to have your labels with your units. And no, we are not just labeling it X, Y. We all know what that means, ladies and gentlemen. Okay, so now I need to go back and graph my data. Notice these two like little weird Z's right here? That is telling me that, no, I know I have 0 through 14 numbers here and 0 through 28. I'm just kind of skipping a few so I can look more up towards and graph my data and actually see my data. So you can skip numbers like that by putting those little weird Z symbols. Alright, so this first one is 2136. I'm going to go to 21, then up to 36 and plot my point. Okay, 2141. So back to 21, up to 41, plot my point, and so forth, going through all the data. Okay, so now we're going to draw a trend line. Basically, our trend line, we're going to say, okay, here's all my points. I need to kind of draw a line that kind of shows me the way, the direction that the points are going. So, this is my trend line. Now, everybody's going to do a trend line a little bit differently. Some may have a steeper trend line more towards this dot. Some may have a flatter trend line more towards this dot. It all kind of depends on who draws it. And so you might have to be a little off. Now the calculator will give you a very accurate line, whereas when we're actually doing it by hand, we'll get a little less accurate line sometimes. Alright, so now I need to write the equation of the trend line. So what I'm going to do is pick 2 points after I draw the line. So I've got the drawn line. I'm going to pick a point here and a point here. And I need to find what those coordinates are, 1430 and 1939. Notice these 2 points are not in my data. That's because my trend line won't necessarily have all these numbers or all these coordinates on my line. So remember that. Okay, so I'm going to find the slope. Do y2 minus y1 over x2 minus x1. So 39 minus 30 is 9 and 19 minus 14 is 5. So here's my slope. Then just pick one of the points that you picked on your line and do your point slope equation. So y minus 30 equals 9 over 5 times x minus 14 if you use the first point. And y minus 39 equals 9 over 5 times x minus 19 if you use the second point. Either one's correct. Both of them are actually the equation of that line. So you can go either way.